different systems of equations in two variables. There's going to be a couple different ways that we can solve each equation. So for example, I might give you the two equations. So x minus y equals 5 and 2x plus y equals 1. So this is my system of equations right here. And I'm going to tell you something maybe most of the time you'll have to solve for your answers. But so if we're just checking your answers, what we're going to do is I will give you 2, -3. So this will be part of your problem that will say like check the answer or something like that. What I'm going to do is plug, this is my x value and this is my y value. So I'm going to plug both of those values into the separate equations, both for the x and y respectively. So for the top equation, I will have 2 minus -3 equals 5. I want to make sure that this works out. Okay, so 2 minus -3 is 2 plus 3, which is equal to 5. So 5 equals 5. So this is true, so this is a good solution for that one. Now I'm going to also check it out in this solution. In this equation, I'm sorry. So I'm going to have 2 times 2 plus -3. I want to check to make sure that that's equal to 1. I'm not going to move things from different sides. I'm just going to work with one side at a time. Okay, I can simplify both sides at the same time if I needed to. This case I don't need to because I just have a 5 and a 1 over here. So then I'll have 4 minus 3. Is 4 minus 3 equal to 1? Yes. So it's a good solution for this one as well. So if you need to check your answers, this is the steps you'll do to check your answers. It doesn't matter that the 5 and the 1 are not the same, just as long as I have the same thing on the same equation. That's what actually is going to matter. So the one way that you guys will probably want to do this is actually graphically will be one of the easier ways to solve them. And you can always use solve it graphically as long as we are in two variables. And that's all we're going to be in for this section. So I have x minus y equals 5. And I'm going to write, still have the same equations. And then I have 2x plus y equals 1. I can plug in points to graph. The easiest way that I've always thought to do it is to actually solve for y. So in this first equation, I will subtract x from both sides. And then I'll have -y equals 5 minus x. But I want to actually solve for y so I can plug it in my calculator. So I'll divide both sides by -1 or multiply by both sides by -1, however you want to call it. All it does is change all my signs. So then I have y equals, I'm going to write my x in front just because that's standard. And I have a positive x and a -5. Okay, this one when I solve for y, I subtract 2x. I'm going to write the 2x in front of the 1 because I like the x's in front. And I will have a -2x plus 1. If you don't have a graphing calculator, which you are all, I think you all have access to one at least. This is not a very good set of axes. They're dotted, but it's cool. And then what I'm going to do is actually go plot these points. So x minus 5 will be down 5. 1, 2, 3, 4, 5. And it has a positive slope of 1. And we haven't graphed stuff in a very long time. And then I have y equals -2x plus 1. So that's right here. And then I'm going down 2 over 1. Down 2 over 1. And then I plot those lines on here. I will get a solid one. And I will try to make it, I did not make that one very good. Okay, so that's a fairly good line for me. We'll just all be happy with that. We're all going to pretend that we're happy with these lines. And it crosses right here at 2, -3. So right 2, down 3. Okay, so when you graph those lines, you will be able to see those. If we don't like graphing things by hand because we don't like doing that much work anymore. And so I'm going to go into my y equals. My y equals, since I have solved for y, so in order to use your calculator for graphing it, you have to put it into your y equals. So I have x minus 5, and my other line is -2x plus 1. I go look at my graph. Whoops, and I have a really bad old graph. I'm going to push my zoom because I have it set at a weird box. I push my zoom button, and my sixth one is the standard 10 by 10, or actually it's 20 by 20 window, but it's good. So actually, I'm going to say my graph here looks pretty good. And what if I want to look at this? Whoops, I don't really want to drag and drop it. You can pretty well tell that it's there, but it might be a half if you weren't sure about it, and this is how you were actually choosing to solve it, and you were not choosing to actually plot your points and see them precisely where they are. You can go into your second trace menu, which is your calculate menu, and I want to find my intersection. So we did this in our last section, I believe. So I do intersect. My first curve, I know they're not really curves, they're line. I hit enter. It will automatically pop, the little cursor will pop over to the other line, and I'm going to hit enter again. Okay, it tells me to guess. Really what it's wanting you to do is just kind of put the cursor actually close to where the intersection is. On two lines it doesn't matter because they're only going to cross once. I have 2, -3. So that's good. We knew that. I was told that. We just kind of wanted to check that. Okay, so that is one way to actually solve things. Sometimes, though, we're going to get graphs that might look a little bit differently. And maybe, so let me draw some axes here. If my line, so this is my set of axes. I'm going to draw 3 different sets because there's really like 3 scenarios that can really happen. And what's going to happen is I could have lines that cross just like those last ones did, and they cross in one specific point. That is what we call consistent because it has a solution. And the lines are obviously not parallel because they do not go together, so it's considered independent. Okay, the next type of thing that can happen is I could actually have parallel lines. If I have parallel, so I'll just make a little note that this will always happen for parallel. And what happens is we call this inconsistent and independent. So these will never cross, and there is no solution whatsoever for these. So if I was asked to find a solution, I would say no solution. And over here, I only have a one single solution, which basically just means that you can actually find it. Over here, I might have one line, and then what's going to actually happen is I will have another line just right on top of that line. Okay, so these are, in a way, they're parallel lines because they have the same slope, but they go through all exactly the same points. What they say is lines are identical. And sometimes they give you equations that you cannot actually tell they're identical by just looking at them. There are infinite solutions. And we call this, with the same kind of 2 words, we call this consistent because there is a solution, and dependent because they change at exactly the same time. Okay, they change, so as this one, if this is at 2, the same line, they both have the same value. They're both at 1. And it's really weird to try to name it 2 different lines, even though you know that they're the same line. Okay, so these are the types of answers you will get, and based on the number of answers you get, you will basically be able to tell me how many times each graph, if I were to look at the graph of them, whether it crossed or not, whether or not you're even looking at the graph. So sometimes we don't want to actually solve it by using the graph because, well, it only works even like at this, it could have been over a little bit. If it was not actually exactly at 3, we would never have known because, well, we did this work. But sometimes we can't see everything that's going on. So what we're actually going to do is we're going to learn a couple different methods. One of them is the substitution method. So hopefully you guys have done this before. And we're going to solve the same set that we've already been solving because we already know what the answer actually is. And that way it's a really easy way to check our answer and learn new things. Plus y equals 1. So this is our first equation, this is our second equation. So the first thing that we're going to do, since we already have one of them solved for y that we did in the other equation, and it doesn't matter which one we actually solve for y, since I will do the top one just because we already had it. So I'm going to look back a couple pages and see what I got when I solved for y. So I got y equals x minus 5. So this is the same thing as y equals x minus 5. So what now I'm going to do is plug this equation, this side of the equation, in for this y. Okay, I have to just have something equal that I can plug in there. So I will have then 2x plus, and I like to leave it in parentheses, just it doesn't really matter here since it's a plus sign, but if I have a minus sign or some numbers in front of that y, it's going to look really different if I don't remember those parentheses. So equals 1, I can add like terms. I don't really need to drop the parentheses before I add like terms since I can see that nothing's going to change from in front of these parentheses. So I have 3x minus 5 equals 1. I'm going to add 5 to both sides, and I get 3x equals 6. I'm going to divide both sides by 3, and I get x equals 2. Okay, congratulations. That's what we got before. We know that's what we should get. Now what we have to do is go back in and plug this into either one of these equations. Okay, it absolutely does not matter which equation we use. Okay, since this one is a nice linear equation, and I could also plug it into this equation over here. Since I will be looking for y, that's actually what I'm going to do is plug it into this equation I solved for, which is, I'm going to say, is generally a pretty bad idea, so maybe we won't. Because sometimes if you don't solve this correctly, we'll get like totally crazy wrong answers. So I'm going to go ahead and put it back in this original equation. And so it was x minus y equals 5. I plug in 2 and I'll have 2 minus y equals 5. I'm going to subtract 2 and I get negative y equals 3. Divide or multiply by negative 1 and my signs change and I get y equals negative 3. I always write it back as an ordered pair and I have 2 common negative 3. The next method we're going to go over is called our elimination method. And I hope you guys are already familiar with this, because this will be much easier if you are. If not, it's cool. Elimination method, I can't spell method, that's a D. Elimination method, using the same equation that I had before, or maybe not. Yeah, I want to use the same equation. So I have x minus y equals 5. And 2x plus y equals 1. Okay, the elimination method is easiest if you know when to use it. Since I can quickly see that these have opposite signs and I always want them to have opposite signs, find your numbers with opposite signs. If they don't, it's okay because we can change it. So I might go through this way, this one, oh my gosh. Find numbers with opposite signs. And those are the ones that I'm going to add with same numbers. We basically want the same numbers with same numbers. Or hashtags with the same hashtags in front of them. So I'm cool like that. Okay, so basically think about this, that this has a 1 in front of both of these, and I want them to be opposite signs. Okay, what I'm going to do is just add these two things together. And I always like to do it this way. There, you can do an addition and a subtraction way. I think that's more confusing because then you have to remember if you're adding or subtracting. I always try to get them opposite signs and then I just straight add them. So I have 5 plus 1 is 6. Okay, negative 1 plus 1 goes to 0. X plus 2x is 3x. I have now a linear equation that I can solve. They were all linear equations, but now I have a linear equation in one variable that I can solve. When I divide by 3, I get x equals 2. Now I have to go back and use my other steps from my substitution stuff, and I'm always just plugging this one back in to whatever equation I'll do. I'll do the other equation this time. So I have 2x instead of x, I have 2 plus y equals 1, solving for y. 2 times 2 is 4 plus y equals 1 minus 4 minus 4. Y equals negative 3. Go back and rewrite it as a single point. Okay, so let's do a couple different ones using a couple different methods. And we will show you what happens when we get things that seem and act really, really weird. Okay, since substitution is generally the easier one, I'm going to go over how to do the elimination one because that's the ones that kind of give people problems, even though it really shouldn't be too bad. So I might give you the equations. X minus 3y equals 1, and negative 2x plus 6y equals 5. So what I'm going to do is, since I don't actually have any of the same numbers in front of anything, what I'm going to do is try to multiply. I'm not going to try to. I'm going to multiply one of the sides by whichever one I want to eliminate. So, and I can multiply both equations if I need to. I'm going to multiply this top equation by 2 because I can see quickly that the x's will cancel out. So then I'm going to just rewrite this equation once I multiply everything. I'm going to write it underneath, and then I'm going to ignore the top equation. So 2 times x is 2x. 2 times negative 3y is negative 6y. And then 2 times 1 is 2. But there's kind of some problems here when we go to add these up now. So we're ignoring this top one. We're adding these up because we always add. And I have negative 2x and a positive 2x, so that will be 0. And then I have 6y minus 6y is also 0. And 5 and 2 give me 7. So I get the equation 0 equals 7, which is like, hey, what's going on? I have no idea what's happening now. Okay, because 0 is not equal to 7. I'm not crazy. Did I do something wrong? Is generally what you think. And that's always what I think whenever I thought I would always do it wrong. And that's not what happens. It actually is just this is something that happens. If I get something on this, I have no idea what my lines actually look like, but I have parallel lines. So I have parallel lines, which means I have no solution. And I absolutely always hated these in high school because I just knew I had to have done something wrong. And I didn't do anything wrong. There was just actually no solution. Okay, so the other thing that can happen is if I give you the equation, so this will be a totally separate thing on this side. If I have 2x plus 3y equals 6 over the equation 4x plus 6y equals 12. And if you don't like the order that they gave it to you in, you can actually put either one of them on top or bottom, however you want to. It doesn't really matter. I want to get rid of the x's or the y's. It doesn't matter which one you pick. And I'm going to multiply this bottom one. So not the bottom one because that makes it really hard. I'm going to multiply the top one by 2. Because if I take 2 to get to 2, or 2 times 2 would give me 4. But if I look at it, that will be the same sign, so I'm actually going to do it by negative 2. So then I rewrite everything that I multiply by, and I will have negative 4x. And then I'm going to get negative 6y again. I don't like that right now. I can kind of already tell just looking at it that I'm not going to like it. I have negative 2 times 6 gives me negative 12. Negative 4 and negative 4 Or positive 4 and negative 4 give me 0. 6 and negative 6 give me 0. 12 and negative 12, well, that also gives me 0. Does 0 equal 0? Why, yes, it does. Okay, since 0 equals 0, and this is true, I have an infinite amount of solutions. Infinite amount of solutions. I'll just write infinite solutions, which means that these two lines are on top of each other. They are the same line. Okay, so over here when I did this, 0 is not equal to 7, so this is a false statement. So just kind of think if it's true, I have infinite. If it's false, and it doesn't have to be 0. For example, if I just totally has nothing to do with these problems, if I got 11 equals 11, I would have infinite solutions. If I had 1 equals 2, I would have no solutions. Okay, so just examples of things that may or may not happen. If you got x equals x, I would have an infinite amount of solutions. If you get x equals a number, like if you have x equals 3, that's actually just x equals 3. Okay, that means I need to plug it back in and find it, and then I actually just have one solution. So if I remember like looking at my graphs, that would be when they actually cross. Okay, so if you get x equals a number, one solution. Number equals the same number, infinite. Number equals a different number, no solutions. Okay, the reason why systems of equations are useful is because we can use them to make more money in a way. So I'm going to read you a problem. It says at Max Munchies, caramel corn, so I'm just going to say caramel corn is $2.50 per pound. Is mixed with honey roasted mixed nuts, and mixed nuts are equal to $7.50 per pound. That's an LB there. And so they're mixed together, and then we get a 20-pound bag of a mixture, which is going to be both of these things, and 20-pound bag, and that will be equal to $4.50 per pound. So this was just kind of trying to be a quick recap of the word problem here. What you're actually going to do each time, and it's hard sometimes to actually make yourself write it, and it makes it about 100 times easier if you actually write it. I'm going to make like a little chart. Okay, it's going to have price per pound. I'm going to write dollar signs. So dollars per pound. And then I'm going to have also the number of pounds. And then the value of the mixture. And then I'm going to figure those things out for caramel corn. Then I'm also going to do that for the nuts and then for the mixture separately. Oops, mixture. So my caramel corn is $2.50 per pound. So in this little box I have $2.50. I don't actually know the number of pounds of caramel corn. So I'm going to say X. I could say C. It doesn't matter. I kind of like using the same letters. So I have C for caramel corn. And then the value of that is 2.50 times C. Okay, the value is I would take the amount of money times the amount of pounds that I had, and that's basically what I would end up paying if you plugged in the number of pounds you had. Then I'm going to do the same thing for my nuts. I paid $7.50 for each pound of nuts. Nuts are obviously, I can't use the same variable that I used for caramel corn, but I'm going to call it in. Okay, the value of that, how much would I pay if I bought in pounds, would be $7.50 times in. Now for the mixture, I was told how much the mixture costs, and that was $4.50. And I am actually told how many pounds of this I bought. Was told that, or somebody bought 20 pounds. Okay, I should know what the value is, and that will be 450 times 20. So we, of course, don't like doing math in our head anymore. So 450 times 20, and that gives us 90. So the value of our mixture, we should pay $90 for that mixture. Now we have to figure out actually how much caramel corn we got and how many nuts we got. So I'm going to go straight across. I'm going to basically, you don't necessarily have to circle it, but that's really not an equation because that just has a bunch of numbers. But these two bottom pieces are actually going to give me my equations. So what I'm going to have is C plus N equals 20. This says the amount of candy corn and the amount of nuts I bought was 20 pounds, the amount of pounds of each that I bought. The amount that I paid for the candy corn, so 250C plus 750C, or N, I'm sorry, is equal to $90. I know that I now spent $90, and then I'm going to solve this equation with substitution, elimination, whatever you actually want to use. If you wanted to graph these, sometimes then it would be easier to say x and y just so that I know what I'm trying to solve for when I go to do it in the graph. Okay, what I'm going to do is use elimination, and the one that I want to eliminate are my c's. Doesn't matter which one you actually pick, you just have to make that choice. Okay, so I'm going to multiply this top one. I probably shouldn't have put that line there first. So I'm going to multiply this top one by negative 2.5. So I'm going to rewrite it down here. I have negative 2.5c minus 2.5n equals 20 times 2.5, which will give me 30, I think, 50. I'm really bad at math today. It's good. That's why we have calculators on those days. Okay, when I add and subtract these things, I'll have 2.5c minus 2.5. That gives me 0. 2.5 minus 7.5 minus 2.5 is just 5n equals, since I'm adding these guys, it will be 140. And then I will divide that by 5. And then that gives me n equals 28. Okay, I still have to find the amount of candy corn that I made. And I am looking at this, and this answer doesn't make sense to me. So what I forgot to do was actually plug in a negative with that 50. So then it should be 90 minus 50. 90 minus 50 is 40. 40 divided by 5 is 8. So I bought 8 pounds of nuts. The reason why I knew I had done it wrong was because I had a 28. I only bought 20 pounds, so I couldn't possibly have 28 pounds. So then what I go through and do is I plug that back into either one of my equations. I think the top one's easier because then I don't have to multiply by different types of numbers. So I had c plus n equals 20. I'm going to plug in 8 for n, so I have c plus 8 equals 20. And then I know that c equals 12. So I got 12 pounds of candy corn, caramel corn. That'd be a lot of candy corn. I think I'd throw up a little bit. And 8 pounds of nuts. And it's also a good idea anytime you do word problems to check to make sure that these two numbers also make sense in the money equation that we made. So yeah, it made sense in the pound equation that we made, but what about the money one? So if we took 250 times caramel corn, which was 12, and we added 750 times 8 for the nuts, would that equal $90? Okay, so 250 times 12, so that would be $30 here, plus 750 times 8 is going to be 60. So that is $90. So that works out, that checks. So just a good idea. Maybe not necessarily do it on paper, but make sure you go through and do the steps in your head, at least on your calculator, real fast to check to make sure everything makes sense. Okay, then the next type of equation that we'll have is going to be a distance, rate, and time problem. So the problem is an airplane flies a 3,000-mile distance from Los Angeles to New York with a tailwind in 5 hours. So with tailwind is 5 hours. The return trip against the wind, so against tailwind, which would be a headwind. So I'll just write a headwind. So with a headwind takes 6 hours. Find the speed of the airplane and the speed of the wind. So what you're going to do, we're going to make the same kind of table that we made for the pounds and the price of the nuts. So hopefully you guys know from science, math, I don't know where exactly you learn it anymore, is that I have distance equals rate times time. I've used to always see the little distance rate triangle time, and you make like this little thing. Okay, and we make that little triangle. So if I'm looking for rate, my formula equals the two things that is not rate, which is distance over time. And then if I'm looking for time, it's distance on top with the rate on the bottom. You can get these from following either one of them. I just kind of always like the little triangle deal. Okay, so what I'm going to do is in my little table, excuse me, I'm going to make a column for distance. I didn't spell distance very good. You get the idea. One for rate and one for time. Okay, when it asks for speed, speed is the rate. Speed is rate. Miles per hour, distance is miles, time is the hours. We're going to make two different things with tailwind and then with headwind. Okay, I'm going the same distance both ways, so that doesn't matter. That's the same. That's 3,000. My formulas with the wind, so either way the direction, I'm assuming that the planes are going at the same exact time. It's not the same plane, it's just the same time. So they're facing the same winds, going at the same time. They're just going in opposite directions. Okay, so my rate here would be however fast the plane is going, obviously, but then I also need to add and subtract the actual wind that's happening as well. So with the tailwind, what that means is that it's pushing the plane. So a tailwind is going the same direction the plane is going, so we're adding that speed. The headwind, the wind, you have like your little plane here and your wings, and this is an awful plane that I'm drawing. Sorry, I'm trying. And a headwind means that the wind is coming at the same direction against the plane. And a tailwind, on the other hand, would be pushing it. Okay, so they're going the same direction and opposite direction. So when I'm going the opposite directions, I have to subtract the speed of the wind. Okay, I am told the time. So with the wind, with the tailwind, sorry, it's 5 hours. With the headwind, it's 6 hours. Okay, and you have to know your distance equals rate times time formula in order to know what to do. Okay, so on the other formula that we did, we just added these things to get that. But for a distance, rate, and time problem, what we're going to have to do is multiply them because the rate and time is getting multiplied. So distance, 3,000, equals rate, which is P plus W, times time, which is 5. Okay, my other formula is 3,000 equals P minus W. Okay, anytime I have a plus or a minus inside of my whatever I have in my column, make sure that you are put in parentheses around them. Okay, I could distribute that 5 throughout things, but since it's already out by itself, what we're going to do is actually divide it. So we will divide by 5, and here we'll divide by 6. Okay, so my two new formulas will be, I'm going to erase my terrible map. And what I'm going to do is then say 30 or 3,000 divided by 5 will give me 600 equals P plus W. And 3,000 divided by 6 will give me 500 equals P minus W. My pen is having a spasm again, sorry. And if I look at this, you have to decide which way to do this. Do I want to try to graph it? Do I want to use substitution or elimination? Anytime, so remember that these are all ones in front of everything. And if I look at this already, I have a positive and a negative W. Okay, so what I'm going to do is I'm just going to add them straight up and down right now. So 500 plus 600 is going to be 1100, and that will equal 2p because these will add to 0. 2p, so then I'll divide by 2, and 1100 divided by 2 will be 550. That means the plane is moving at 550 miles because we were initially given miles per hour. So you have to actually know, you have to be able to state your units and actually do that. You could have done MPH, sorry. So 550, now I have to figure out the speed of the wind. I can plug it back into either one of the formulas, that doesn't matter. Okay, so I'm going to plug it into this one for no reason. It didn't really matter which one. So then I will have 500 equals 1p, so 1 times 550 minus w. So minus 550 minus 550, I get negative 50 equals negative w, divide by negative 1, and I get w equals 50. Would that make sense in the context of both of the problems? I need to be able to use it either way. I'm just going to do this quick on this top one. I'm going to plug it back in. I'm just going to talk myself through it. I'm going to have 600 equals 550 plus 50. Is that equal to 600? Yes, it is. So it works out on both of these. Should be the same because I'm pretty sure that we can multiply and divide easily right now. Okay, still it might be a good idea to plug it back into these two formulas. Okay, so then you're going to write like a little sentence. The plane was going 550 miles per hour and the wind was 50 miles per hour. The other type of questions you will have are supply and demand, and they're usually really nice because they actually just give you the equations already and you don't have to figure out the equations, because that is really about the hardest part on these ones once you get to the actual word problems. But I want you to do homework on page 490. I want you to do numbers 1 through 6, and then I want you to do 9 through 39 by 3s. And then I want you to do 41 through 44. And those ones are kind of nice because they actually give you little hints with them. So they look kind of gross, but they're really not too bad. Just use whatever hints they give you. Just kidding. Instead of 41 through 44, just do 41 through 50. And the rest of those ones are true and false. The other ones give you hints. And then 51 through 78 by 3s.